Hello and welcome everyone. I am Avinash Sahu, your physics guru, and today I am in front of you with a new video of motions. Last time we discussed about the term reference point, distance, displacement, as well as we did some numericals on distance and displacement. In this chapter we study about the term speed. Okay, speed, and as well as we discuss about the term motion in straight line. Motion in straight line. So first of all we discuss about the term motion in a straight line. Okay, so if I am talking about the motion in a straight line, then we can say that it is the simplest type of motion, because out of the three coordinate, you know about the coordinate x, y and z, the body moves along only one axis. You can say that, suppose x axis. Okay, only one axis. It may be x axis, it may be y axis, or it may be z axis, but out of these three coordinates, body moves only in one dimensions. Okay, body moves only in one axis. For example, our topic is motion in a straight line. In a straight line, and I'm saying that in motion in a straight line, and I'm saying that out of three coordinate, x axis, y axis, z axis, okay, out of these three coordinates, body moves only in one dimensions. It means it may be x axis, it may be y axis, it may be only z axis. For example, suppose that there is a straight road and a car is moving along this straight road, then if I'm saying that if I'm suppose that this is the origin of the car, this is the starting point of the car, it may be considered as reference point. Okay, and the body moving along straight road, and I'm saying that this road is along a x axis. Okay, along a x axis. You can consider that this is y axis, okay, or z axis. But if I'm consider that this straight road is along x axis, then how you determine the position of this car? Then you simply, the change occur only in x axis. Okay, suppose car is starting point, car of the is this, but after some time it moves along this and it reach at point this, then position is changes, but it's changes only x axis position, not y axis or not z axis. If you can take another example, okay, you can take another example, only one axis changes. Suppose that there is a rocket and start to going in upward directions. Okay, then you can consider that this is a x axis. Okay, this is, you can consider this is y axis, and this is z axis. Okay, you can say that this is z axis. Then position changes only in z axis, because there is no change in the x axis, there is no changes in the y axis, only changes occur in z axis. Okay, suppose its position is, when it is at ground, its position is at 0, but after some time it reaches at position this, so its value is changes. So only y axis is changes. So you can say that out of these three axes, if only one axis is changes its position, then you can say that motion in straight line. You can also say that this is one dimensional motion. Okay, you also say that this is one dimensional motion. Okay, so what is motion in a straight line, or what is, or you can say that what is one dimensional motion? When out of 3 coordinates only 1 coordinate changes and other 2 are remains, so you can say that such kinds of motion is said to be one dimensional motions. To describe one dimensional motion, only 1 coordinates are required. 1 coordinates are required. Okay, so this is said to be one dimensional motion, or motion in a straight line. You can say that some other example of motion in a straight line, you can consider that there is a railway track. Okay, there is railway tracks and a train is moving along a straight road, then straight this track. Okay, then this is also an example of a motion in a straight line. Okay, but our today's main topic is speed. Okay, today we will discuss about the term speed. So today's topic is speed. Firstly, you give the symbol of speed is V. Okay, the symbol of speed is V. Now, how you define speed? Okay, then suppose there, take an example. Okay, take an example. Suppose that there is a straight road and a object is moving along a road, and its reference point is O, and it starts from its reference point and covers some distance, say 20 kilometer distance. Okay, 20 kilometer. For easy you can take it 20 meter. Okay, suppose that it's cover some distance, reach at point A, and by cover 20 meter distance in 5 minutes. Okay, in 5 seconds, take it second. Okay, in 5 seconds. Then how much distance it cover? It covers 5 meter distance, but in how much time? In 5 seconds. Okay, if I'm then question is that if it covers in 5 seconds, object covers distance is 20 meter. Okay, in 5 seconds objects cover distance 20 meter. Then question is, in 1 second how much distance it cover? It covers 20 meter by 5 seconds. 20 meter by 5 seconds, it means it covers 4 meter per second. That is known as speed. That is known as speed. So what is speed? How you can define speed? Speed is the distance covered by an object in 1 second, in 1 minute, in 1 hour. You can say 1 minute. Okay, in 1 minute, in 1 second, in 1 hour. What is so 1 hour? So by taking its 1 minute, 1 second, 1 hour, you can take it in unit time. In unit time. What is the meaning of unit time? Unit time means 1 second, 1 minute, 1 hour. Okay, it may be unit time means unit means 1. Okay, then what is the speed? Speed means how much distance covered by the body in unit time. This is the definition of the speed. The distance object is set. Speed of an object may be defined as, how you can define speed? Speed of an object may be defined as distance covered by an object in unit time is called speed. Okay, distance covered by an object in unit time is called speed. Okay, you can also say that the distance covered in 1 second, the distance covered by the object in 1 second, distance covered by the object in 2 seconds or 1 minute, 1 hour, then it is said to be speed. So formula becomes speed. Formula of speed is distance covered by the body and time taken to cover this distance. Okay, and time taken to cover this distance. In short, you can say that speed, V mathematically or symbol, if you using the symbol, then it becomes V is equal to distance S by T. What is the S? The symbol of distance is S. Okay, the symbol of distance is S, time is T, and speed is V. Okay, then what is its SI unit? If I am talking about unit of speed, then first is SI unit. Okay, firstly you tell me the SI unit. Okay, if I am saying the distance, the standard unit of distance is meter. Okay, and the standard unit of time is second. So its unit becomes meter per second, or you can write it as also. Okay, meter per second is its SI unit. Then second is, what is its CGS unit? Okay, CGS unit centimeter gram second, CGS unit. Okay, CGS unit of speed is distance is in centimeter divided by second. Okay, or simply you can write as centimeter per second. Okay, centimeter per second. And there is another unit also. You can say that other unit. Okay, there are other unit of speed is kilometer per hour or kilometer per minute or kilometer per second. Okay, it may be, or meter per minute, it may also be meter per minute, millimeter per second. Okay, these are some other unit, but most popular is kilometer per hour, centimeter per second, and meter per second. Okay, this is very important unit of speed. Now there is another property of the speed is a scalar quantity. Speed is a scalar quantity. What is the meaning of scalar quantity? Scalar quantity means it has only magnitude. It has only magnitude. It does not depend upon its direction. Okay, then how you can say that it does not depend upon its directions? Because we know the speed of the body is distance upon time. And suppose that there is a body which is moving on this path. Okay, this path. Okay, the exact path is 100 meter. Okay, suppose consider that the exact path is 100 meter and a body wants to move. Then you found that the path at different direction of the body is different at different point here, and suppose that total time taken by the body is 5 seconds, then speed of the body is 100. What is the distance? Distance is the actual path covered, and the here actual path is 100 meter. Actual path is 100 meter. So 100 meter divided by time is 5 seconds, so it becomes 20 meter per second. This is the speed of the body, 20 meter per second. What is the meaning of 20 meter? 20 meter is a magnitude. Magnitude means numerical value. Okay, it has numerical value. But what about the direction? Okay, if you think the position P, then you found that the direction of the P is like this. Okay, when you discuss the position of Q, then direction of the body is in this, and at this position PQ R, then direction is this. So at different point the body has different directions, so it means it does not depends upon direction. Okay, next topic is next properties is it is a derived quantity. Okay, it is a derived physical quantity. What is the why it is said to be derived physical quantity? Because the formula of speed is distance upon time. Distance is a fundamental physical quantity, time is also a fundamental physical quantity, and speed is derived from the, what is the meaning of derived physical quantity? Those physical quantity which are derived from fundamental physical quantity is said to be derived physical quantity. And we know that distance is a kind of length, time is time, so these both are the fundamental. And how we calculate the speed? With the help of fundamental physical quantity, so we can say that this is a derived physical quantity. Okay, and next point is speed is always positive and never be zero. That is, v is not equal to 0. It is always a positive quantity. You can take it with an example. Says that a person starts from his journey from point A, and after traveling some distance it again reached at point A again. Then you say that distance is 0. No, actually what is the definition of distance? Distance means the actual path covered by the body. So this actual path is not equal to 0. It means suppose that this is the actual path and this is 100 meter, then actual path is not equal to 0, it is equal to 100. How much distance cover? It covers 100 meter distance, because it covers 100 meter path. Okay, so distance is 100 meters. So you can say that. So, and how much time it takes? Well, again it takes 5 seconds. Then speed is equal to 100 divided by 5, it means 20 meter per second. It is always positive. Okay, one thing is that it is always positive, or it is never be equal to 0. If a body again comes to its original position, then you say distance is 0. No, actually when it moves from the some distance, after that it comes at this point again, it means it covers some path, and the path covered by the body is called to be distance. Okay, so it is never equal to, distance never becomes equal to 0, so speed is also never becomes equal to 0. Okay, never be 0. Okay, it is always positive. Why? Always because if a body is in motion, then definitely they cover some distance, and distance is always positive, so it is so speed is also positive. Okay, now these are the okay. So this is the these are the some properties of speed. Now we discuss about the term types of speed. Okay, now we discuss about types of speed. Types of speed. Types of speed. So first of all, we discuss about the one of the type is uniform speed. Okay, uniform speed. Okay, the second one is non-uniform speed. Third one is average speed, and fourth one is instantaneous speed. Okay, instantaneous speed, average speed, non-uniform speed, and variable uniform speed and non-uniform speed. Okay, there is another name of uniform speed is constant speed. Okay, constant speed. Okay, what it means? It means you can define constant speed in two ways. Okay, two ways. Number one is if an object covers equal distance, if an object cover equal distance in equal interval of time, equal interval of time, then body is said to be uniform speed. If a body covers equal distance in equal interval of time, then it is said to be uniform speed. Or if a body is moving with same speed, if a body is moving with same speed, then if a body is moving with the same speed, then it is said to be constant speed or uniform speed. What is it means? It means a body is moving with the same rate. It means in equal interval of time it covers equal distance. Suppose that if a body covers, this is the distance and time. At time, when a body is initially at its 0 position. Okay, after time 2 seconds, covered distance 10 meter. Okay, 10 meter, and after 2 minutes 2 seconds it covers distance 20. After again interval 2 it covers distance 30. It reach at position 30. It means you can say that the position of the body is here. Okay, its position is at 0. Okay, origin point. After some times it means 2 seconds is reached at position 10 meter. After some times again after 2 seconds, it means when the time is 4 seconds. Okay, it reached here at 2 seconds. We observe it after 2 seconds. After 4 seconds its position is 20. After 6 seconds we observe that it is at 30. Then how much distance it covered in first interval? Okay, in first interval of time, it means in first 2 seconds it covers how much distance? First time interval is 2 seconds, is 10 meter. It means how much distance it cover in 1 second? 5 meter per second. Then its speed is 5 meter per second. It means here speed is 5 meter per second. It means it moving with the speed of 5 meter per second. Okay, if the position is at and now from this time interval, during what is its speed? When it moving from this position to this position, then what happened? The time taken, the time interval is again 2 seconds. And how much distance is covered in 2 seconds? 20 minus 10, it means 10. It means speed is again 5 meter per second. It means calculate the speed, how much distance what is the speed in this interval, 2 seconds and 4 seconds, then you find that the distance covered in these 2 seconds is 10. It means 10 divided by 2 seconds, so it is equal to 5 meter per second. Now again you calculate the speed, then you found that its speed is 30. How much distance is covered? Next 2 seconds. In next 2 seconds it covers 30 minus 20, it means it covers 10, so its speed is again 5 meter per second. So you can say that when it moving with the 5 meter per second, 5 meter per second, 5 meter per second, then body is said to be uniform speed, constant speed, fixed speed, okay, same speed. If a body is moving with the same speed, then same speed, here is again 5 meter per second, here speed is again 5 meter per second, it means uniform speed, okay. And body covers equal time interval. In equal time interval, body covers equal distance. In all the cases, it covers 10 meter distance in 2 seconds, 10 meter distance in 2 seconds, 10 meter distance in 2 seconds, okay. It means body covers equal interval of time, equal distance in equal interval of time. A body is said to be uniform motion, a body is said to be uniform speed when it covers equal distance in equal interval of time. So this is the definition of the uniform speed. And the next definition is, a body is moving with the uniform speed, a body is moving with the fixed speed, a body is moving with the constant speed, then body is said to be uniform speed. There is another, sometimes it is used as steady speed, okay. Sometimes it is write as steady speed. Steady speed means constant speed. A body is moving with the steady speed, then a body is said to be uniform motion, okay. So this is uniform motion. A body is said to be uniform motion when it covers equal distance in equal interval of time, or a body is said to be uniform motion, uniform speed when it is moving with the same speed, okay. So both definition are important, okay. Now you define, okay. Now you draw the diagram of this. Now you draw the graph of this situation, uniform speed, distance time graph. Now you draw the distance time graph, okay. This is y-axis, this is x-axis, this is horizon, this is distance, and time is measured along x-axis. So time is 2 seconds, 4 seconds, 6 seconds, 8 seconds. We observe the speed is 10, 20, 30 and 40, okay. Distance is meter and it is in second. Then in 10 seconds it covers distance, in 2 seconds its position is at 10. When it covers 4 seconds, then its position is at 20, okay. Then its position is at 20. When its interval is, when it is at this position, then its value, when it is at 6 seconds, then it covers 30, there is a position at 30. When at 4 seconds, then its position is at, definitely will be 40, okay. So these are some coordinates, okay. Here value is 2 seconds, then when the position of the body is 10 meter, when it's covered after 2 seconds, after 4 seconds position is 20, after 6 seconds its position is 30, then after 8 seconds its position is 40. Then we take equal time interval, and body covers equal distance, then it is said to be uniform motion, and it is a straight line graph. This is the graph of uniform motion graph, uniform motion or uniform speed graph, okay. Uniform motion or uniform speed graph is in equal interval of time, it covers equal distance. This is a straight line. This graph is known as straight line graph, straight line, okay. This is a straight line. A straight line is forms when body is moving with uniform speed. You can check it here, equal time interval body covers equal time interval, body covers equal distances, equal, okay, equal. So it is said to be uniform speed. Now okay, take some example of, give some example of uniform speed. When a car is moving on a straight road and there is no traffic, okay, then we can run a car with the same speed. You can say that 80 km per hour, 80 km per hour. We can speed up a car with 80 km per hour. Average times its speed is same. Okay, when there is no traffic on the road, then we can run a car with a constant speed. Okay, this is an example. You can say that if you can say another example, a train is traveling with the same speed on a straight road, okay, then it is said to be uniform speed, straight track. Okay, now you can take, there is another definition, non-uniform motion, yeah, or speed, non-uniform motion or speed. You again define it in two ways. If a body covers equal distance in unequal time, or vice versa, vice versa means unequal distance in equal time, vice versa means reverse word, okay, in equal time, unequal distance in equal time. Okay, a body is said to be non-uniform motion if it covers unequal distance in equal interval of time or variable speed. A body is said to be non-uniform speed when it moving with different speed, okay, different speed. Okay, how you can say that? Suppose that here is distance measured in meter and time measured in second. Then we found that every 2 seconds you found that distance initially is 0, but after 2 seconds position reached at 10, again in 2 seconds it reached at position 50, and after 2 seconds it reached at position 150. Then what you found? The time interval gap is 2 seconds in equal time interval. After every 2 seconds you found that it covers, in first 2 seconds it covers 10 meter distance, 10 minus 0. In next 2 seconds it covers how much distance? 50 minus 10. It means next 2 seconds it covers 40 meter distance, okay, 40 meter distance. And in next 2 seconds you found that it covers 150 minus 50, you find that 100 meter, it covers 100 meter distance. Okay, so you can say that speed is first interval, speed in first interval, first 2 seconds. In first 2 second time is taken as 2 and speed distance is 10. So its value is 5 meter per second. Next, in the next case you found that the next case time interval is 2 seconds, but it covers 40 meter distance. It means speed is 20 meter per second. And in the next case you found that V3 is equal to, next case, it means in 2 seconds it covers how much distance? It covers 100, so its speed is 50 meter per second. Then you found that in every interval of time it covers different distance. So if a body covers equal interval of time, if body covers unequal distance, then it is said to be non-uniform. Non-uniform speed means different speed, its speed is changes. So this is a non-uniform speed. Okay, what is its example? Example, when you drive a vehicle in a traffic area. Okay, example is when you drive a vehicle in traffic, then you found that your speed sometimes is decreases, sometimes it's increases, sometimes you comes at rest. Okay, so you found that there is different speed. Okay, then you found that there is a different speed. So the motion of the body, motion of a vehicle in a traffic, then it is the best example of the, you can say, the good example of non-uniform speed. Okay, then draw the graph. How we draw the graph of distance time graph? Draw distance time graph. Okay, here y-axis, here x-axis, here origin, and the distance time graph is a curved line. Okay, a curved line. Okay, how you can take equal interval of time. Then you found that 2, 4, 6. Then you found that this time it is 10. Okay, then you found that this is 40. This is, okay, this time is a 50. This is 100, 150. Okay, it means you found that in equal interval of time, you found that this is less, this distance is increased, this distance again is increased. Okay, again distance is increased, and next case its distance is, so in last case its distance is increases. So in equal interval of time they covers unequal distance. Unequal, in this case is large distance is covered by the body. Okay, so in equal interval of time body covers unequal distance, so it is said to be, so this is the graph of non-uniform motion, and the graph is curved. Okay, graph is curved. Okay, so this is the graph, this is the definitions. Okay, so so it is a non-uniform speed. So now next type of speed is average speed. Okay, how we can define average speed? Actually, average speed is the ratio of total distance covered by an object to the total time taken to cover this distance. Okay, a ratio of the total distance covered by an object to total time taken by it. Okay, it means average speed is equal to the ratio of total distance upon total time taken. Okay, it is the ratio of total distance upon my total time taken. It means, suppose a body cover S1 distance in T1 time, then it covers S2 distance in T2 time, and then it covers S3 distance in T3 time, and so on. Then how you can get the average speed? The symbol of average speed is VAV. Okay, AV means average. Speed is total distance. It means S1 distance it covers, S2 distance it covers, S3 distance it covers, and so on. okay, and time taken to cover S1 distance, time taken to cover S2 distance, and time taken to cover S3 distance, and so on. So this is the formula of average speed. Okay, now we understand what is the significance of average speed. So consider, take an example, okay, then we understand the significance of average speed. Suppose that we are moving from A to B. Then we found that when we cover A to C distance, suppose that its speed is we cover 100 meter distance in 20 seconds. There is traffic and we cover 100 meter distance in 20 seconds. Then its speed is, what is its speed? Then its speed is here 100 divided by 20, it means 5 meter per second. When we move from C to D, it against 20 seconds, but in this time we cover 200 meter distance. Then here its speed is 10 meter per second, and finally we cover 10 seconds, D to B we take 10 seconds, and in this time we cover 300 meter distance. Then here its speed is 30 meter per second. Then we found that when we moving from A to C, C to D, and D to B, we found that there is a different speed. Okay, we cover with different speed. Okay, then calculate its average speed. Now you calculate the average speed. Okay, how you can calculate the average speed? Total distance means A to B, how much distance cover? 100 plus 200 plus 300, it means it covers total 600 meter distance. Okay, it covers 600 meter distance. And how much time it takes? It takes 20 plus 20 plus 10, it means in this time it takes 50 seconds. Then this is its average speed. Then cancel out and you get that there is 12 meter per second. Okay, 12 meter per second. It means if a body moving, what is its significance? It tells us the uniform speed. Okay, average speed means it tells a kind of uniform speed to cover the same distance, in same time interval. Okay, that is 12 meter per second. It means if a body covers 5 meter, then its speed becomes 10 meter, then 10 meter per second, then its speed is 30 meter per second. Or in compare of this, if its body covers moving with 12 meter per second, then it covers 600 meter distance, and with in time 50 seconds, then it covers to cover the same distance or same time, then what is it gives about the uniform speed. Okay, it gives about the average speed, gives a kind of uniform speed with which the body moves to travel the same distance in same time interval. Okay, this is its significance. But basically question is asked in numerical, you have to calculate the average speed. And how you can calculate? You calculate with the help of this equation. Average speed is equal to total distance upon total distance upon total time. Okay, with the help of this equation you can calculate the formula, you can get the value of average speed. Total distance upon total, you remember this formula. Okay, average speed. Okay, what is its significance? It gives a kind of uniform speed through which it covers same distance in same time interval. Okay, a kind of uniform. Although the body covers moving with different speed, but it gives a uniform speed with which if body is covered, then it covers the same distance in same time interval. Now last types of speed is Now last types of speed is, it means fourth type of speed is instantaneous speed. Okay, what it means, it means instantaneous speed, the speed of an object at any instant, during its motion. Okay, instantaneous speed, the speed of an object at that instant of time during its motion is called instantaneous. Speed of an object at that instant. What is the instantaneous speed? Means speed of an object at that instant. Take an example. Suppose that you and your friend are moving in a car, and a car vehicle has a device known as speedometer. Okay, speedometer. Okay, there is a you and your friend are moving within a car, and car is moving. Then you found that you asked your friend that what is speed at this point, what is speed at now. You are moving, and when you reached here and you asked to your friend that what is its speed now, then your friend says that right now its speed is 120 kilometer per hour. Okay, 120 kilometer per hour. Okay, so this speed is known as instantaneous speed. Instantaneous speed means speed at that instant. Suppose that your friend is moving, you and your friend is moving, and you ask at point A that what is speed now, then your friend is at 120 kilometer per hour, then this is the instantaneous speed. Okay, now suppose that if you ask at this point and your friend replied at point B, okay, when it reached at point B, that speed is 1, and he says that 130 kilometer per hour. Listen, you asked to your friend at position A what is speed it's now, but when he reached at point B, then he says that 130 kilometer per hour, then this is not instantaneous speed. Okay, so what is the condition of instantaneous speed? Time tends to 0. It means if you ask at point A, then you not replied after time 5 minutes or 10 minutes. Okay, you reply within 1 second, within 2 seconds, within time. Okay, within very short interval of time, you reply the speed within very short interval of time. You saying that you and your friend, again I'm saying that you and your friend is moving are moving in a car, and you ask your friend at point A, then what is his reply? That 120 kilometer per hour. At that instant, that time you ask, and that instant he reply the answer. It means this is 120 kilometer per hour is its instantaneous speed. Speedometer measure instantaneous speed. Okay, you are driving and you say, you look when you driving, okay, when you drive a scooter or any kinds of vehicle, and you see that what is my speed right now, then you see the speedometer. Then speedometer gives the value of instantaneous speed. Okay, you moving, and when you see the speed of the car is this, then this is speedometer measures instantaneous speed. It means speed at that instant. Okay, not replied after 5 minutes or 10 minutes. Try to its minimum. Okay, try to its the time interval change in time tends to 0. Change in time tends to 0 means you answer the value of speed at that instant, not after 5 minutes, after 10 minutes. Okay, that speed at that instant, speed at that time. Speed at B is if you ask that what is the speed at B, if he says that 130, then this is instantaneous speed. Okay, so instantaneous speed means speed of an object at that instant, at particular time. The speed of the body at particular time is known as instantaneous speed at particular time. Okay, the speed of the body at particular time at that instant is known as instantaneous speed. So these are the four different types of speed: uniform speed, non-uniform speed, average speed, and instantaneous speed. Our speedometer measures instantaneous speed. Okay, our speedometer measures instantaneous speed. So what we today learn about the speed. Speed is a total distance upon time, the ratio of distance upon time. You can say that distance traveled by body in 1 second, it is known as speed. Its unit is SI unit is meter per second. Okay, how many types of speed? Speed are different types: average, uniform speed, okay, non-uniform speed, average speed, and finally average speed and instantaneous speed. In uniform speed, body travels equal distance in equal interval of time. In non-uniform speed, body covers unequal distance in equal interval of time. In average speed, body covers the ratio of the total distance upon my total time. And instantaneous speed at a particular time is known as instantaneous speed. Okay, we know that we also study the graph of distance time graph of uniform motion is straight line, and distance time graph for non-uniform motion is curve. Okay, we discuss. In next video we do some numericals. Okay.